NASA Goddard Space Flight Center. My name is Sally Smith, and I work on the science side of the house as an education and mission coordinator and co-investigator for Goddard's Remote Sensing Earth Science program. And I was asked today if I would please tell you about the program to see if you might be interested in signing up for the training next year. So Goddard Remote Sensing Earth Science. Goddard is home to NASA Earth Science. And let's see if my music is going to play in this app. Whoops. These are all of the satellites, Earth observing satellites right now. The kids always think there's 1 and 2 AT&T satellites or Verizon up there, but actually there's close to 2,000 orbiting right now. And when the kids see this, they go, why don't they, crash into each other? Well, they're precise in orbit. NASA is the only organization in the world that monitors the Earth 24/7. NOAA, responsible for climate, and our good partners, they'll put geostationary orbiting satellites, and they'll watch the same part of the Earth, or the specific parts. But NASA is the only funded government agency that watches the entire Earth 24/7. And the value of that is to see how is our Earth changing through time. And through the satellite imagery, we can see that. And everything has improved so much. My question for you is, I don't know if you saw this because it's summer now, how many people have the next generation standards? Next generation standards. I hear you have your iPads with you and that they're working, so everyone please go to this site. We're going to look at the next generation Earth science standards. How many of you teach Earth or environmental science? Okay, that's pretty good. For those of you who do, I just want to ask a couple quick questions, and maybe we can jot them down over here. Are we going to drive the camera? That's nuts. No, that's good. Did you beat the recorder? Sure. Excellent. Okay, if you could please tell me, those of you who teach Earth science or environmental science, what are you teaching in your classrooms? Plate tectonics. We monitor that here at NASA.
Rock cycle?
Rocks? Is that what you said?
Yeah, like a rock cycle.
Rocks. Not only do we do rock formations here on Earth, we are taking them and we are also doing rocks on all of the planets. This summer, my program took the next generation of lunar planetary scientists, and they wanted them to do a field mission. The Mars Reconnaissance Orbiter found basalt columns, but because the satellite is so far away, it doesn't have very good resolution. Those basalt columns are proof that there was water on Mars. And so what they did was they studied the ones in Idaho and Washington State, and we took our instruments out there to study them and compare. What do we see on Earth? What do we see on Mars? Can't get to those to study them beyond satellite, but we can right now study the ones on Earth before they constantly erode away. So rocks, we have resources that can help you. What else are you doing?
Weathering, erosion, deposition.
I heard weather. We need a mic.
Weathering.
Weathering.
Deposition.
Weathering, erosion,
Deposition.
and deposition deposits. And we're doing that on all of the planets as well. What else?
Volcanoes.
Volcanoes. Oh, we're doing that on lots of the planets and their moons and on Earth. That's the way that they cool down. We have lots of information for you about that.
Renewable and non-renewable resources.
Resources. Absolutely. We are, there's plenty of resources on the moon, and we have to know about the geology and the resources, because wherever we're going to go, we can't take everything in a rocket with us. So we have to use the resources that we found. No one said climate. No one said climate change. I was shocked. It's the first time. But that's okay. Don't put that one down. And if they're not doing it, that's okay. Now let me ask you this question. Second question. Earth science problem in your community. What are the things changing in your community, your school, Pennsylvania, where you are, What are the problems that you're having? The recorder.
Groundwater. Groundwater?
Groundwater. And what is your problem with the groundwater?
Impact of natural gas exploration on the groundwater.
Okay, excellent. We can put that down. So these are our problems that we have. Flooding. Good. Anything else? Do you have any invasive species? Anybody have those little gray stink bugs? I went skiing up to Ski Liberty, and I stayed and I rented my little place, and I went downstairs. I said, I need another room because there's all these stink bugs and they're all over the place. I'm not staying with that. I'm from Maryland. I'm not staying with that. And they came down to Maryland anyhow. They're all over the place. Why all of a sudden are we having all these stink bugs? Because what?
There's no predator.
There's no predator for them. No predator. Something's happened to their predator. But our Earth is changing. What happened to their predators?
Well, they came from another country.
Country, they came in on a
They're
little
in
flower.
They've come in, and so there's nobody here to eat them. The other thing is that we're losing a lot of the predators because we're changing the habitat. We're changing the land. The temperatures of our planet are going up or down. Yeah, the temperatures of our planet. Who has the greatest influence on planet Earth? Yeah, you've only been here a very short time in Earth's history, but humans have had tremendous impact, and that's why we need to monitor what's going on. And that's what this program is about. And that's why NASA is monitoring our Earth 24/7 too. Now, are you with me on the next generation standards? Let's see what Earth science is supposed to be taught. If you're on the home page, if you'll please click on where that blue arrow is, your menu, Next Generation Science Standards. Got that? All right, moving on. If you'll please, do you see this page? Click where it says Arranged by Topics. Got it? Okay, and that pulls you to this page and select, scroll down, and you're going to see Earth Science. Look at all the Earth Science. Earth Materials and Systems, that's your resources, but I like the word Earth System, because I've noticed that the next generation of standards, it has what I refer to as blips. When I look at water cycle, I look at one little blip, and you can't get a feel for a blip. But Goddard's doing water cycle, we're doing the whole planet, and we're looking at the water cycle in the terms of an Earth system. How do changes affect everything else? How does the system work here and on other planets? Plate tectonics, that's certainly there, the weather and the climate, biogeology, everything you said. But where my program fits in is really under Earth, human impacts on the Earth system. What are we doing to the Earth? How is it changing? So I'd like you to click on that one, and then click for your grade level, whether you're middle school or high school. And then click the search button at the bottom. Everybody with us? Who said no? We're going to come help you. Somebody over there, help that person. Somebody nearby. Okay, so if you go down, so it's three things. If you'll, there's a scroll on the side. So if you scroll down, you'll see human impacts on Earth systems. And if not, just look at your handout. If you've got a handout, just look at your handout, you'll be okay. Your grade level, and then the search. Then you should see something that looks like this. If you're in middle school, it'll say human impacts, what are humans doing? And if you're in high school, it'll be human sustainability, higher level. And if you click on that link, it'll bring you to the handout that I gave you. And if you take a look at your standards, we want the students, how is our Earth changing? What are humans? What impact have we had on the environment? Should our students, it says students should be collecting scientific data. Students should be arguing. Well, they do that already, but we want them to argue in science. We want them to collect information, and we want them to say, this is what's going on, and I know it because here's the scientific evidence. And I didn't read it, I collected it myself. So we want the people to get into STEM processes, and this is really a STEM process program as well. The students collect the data, and the students create their arguments, and they create solutions. And the RSTEP program, that's what we're all about. We are all about, here's NASA's question. You have teach the water cycle, teach kids the different types of rocks. NASA looks at the Earth. This is a data set compiled by different satellites. Satellites that are watching the atmosphere, satellites that are watching the sea surface temperature. Then we can see a little El Nino warming up around the equator. We're watching the land. We're watching how everything is changing all the time. And here's our big question in understanding the Earth. We live here, so we have to understand it. And it's going to take a long time to go anywhere else. So we all need to be involved in taking care of our Earth. How is our Earth changing? And since we're the biggest changers, what have we done? And how are the things that we're doing affecting the Earth? How do we know? And how can we make it better? What needs to be done in our area? What are the consequences for life on Earth? Not only for us, but everywhere else. Everything is dependent. So Earth is a system. So Goddard looks at it that way. And we have all these satellites, and they touch all of the topics you have to teach, but on a bigger level, in a system approach. Now the RSTEP program is 3-tiered. We make our satellite data available to you, all those satellites you saw, that's available to you. But you know what? Kids can look at that. And satellite data is great for seeing change over time. In Indiana, we had some students that wanted to look at their agricultural students. And so now these tractors have all these GPSs and satellite technology, and the kids were looking at it, and they wanted to know, they're the future farmers of America. And now they're using NASA data to plan how is what they're doing to the land affecting their crops and affecting the land around it. So we started to show the kids the satellite data, and they looked at it from the 70s. And the kids go, where's the lake? Where's the wetland and the lake next to the cornfield? And it's like, your cornfield created this. This wasn't here. You guys, this big, huge lake and this big, huge wetland, it's like the runoff from what you did to the land, this is what happened. And it was a great impact for them. But we can see, especially land development, and we'll do that later. We'll have to put in your address so you can see how land has exploded. And on the ground. So we're 3-tiered. Whenever we do a local mission, the whole goal of our program is to engage local communities in NASA Earth science. And we use the data that you and your students, we want to take your Earth science that you're teaching, we want to take it out of the textbook, we want to take it into the field. And chances are the Earth science that you're teaching, how many of you do it just from a textbook? How many of you have some hands-on activities? That's better. How many of you actually go out into the field and do a mission? See? And it's only a handful. And it's because time, but it's also because of resources. And so this program is going to give you some resources to use, cutting-edge NASA resources and equipment loaned to you so you can implement your missions that are important to your community. This movie that I'm going to show you, how did it get started? Well, the RSTEP program was started by teachers. I worked for NASA headquarters, and I was the NASA JASON liaison. And my job was, wherever Bob Ballard was going exploring, to put a NASA connection to it. And the very first mission I was involved with was in the Channel Islands. Anybody do JASON here? JASON Project Curriculum, Bob Ballard? Okay. Well, maybe you remember the Channel Islands. And so what I had to do, I wanted the kids to do real science. So we took the teachers and we took the science, and they had Anacapa Island. And the problem was this little 2-mile island, and the sea lines were down at the bottom of a cliff. So there was no way to do anything with the sea lines because they couldn't get down there and couldn't get back without boats. And every time they used the boats, the sea lines would be gone. They had a kelp forest, same kind of thing. They could get into the kelp just a little with the freezing temperatures of the water because the broadcast was in January. They couldn't do that. And my job was to help the kids explore this. And so what we did was, we decided, well, the satellite imagery, we can show them that, but kids aren't really interested too much in that. They're great for showing change over time, but they don't get that. Now, your last presenter told you planes are great because they're cheaper. We use little hobby planes from the hobby shop that you can buy, but we integrate them with $35,000 instruments so that they're really high-tech and really cool. And we added ground stations and downlink, and we made planes for education. Instead of doing NASA research, we got cheaper planes, and we put payload in them and downlink systems and created all this technology for it. And so we took our satellite, we took our satellite dish, a big roving van out to download the satellite data for the kids. We took our planes, and we wanted the kids to prep them. And we made separate controls so that the pilots would fly the planes, and the kids would operate the payload. The kids would plan the mission to go see the kelp. The kids would prep the planes, always behind the propeller, total safety. And we decided that Teacher Argos, they should be involved too. So we got the Teacher Argos involved, and then we started taking the best ground in situ measurements we could. And so this is how the RSTEP program got started. I wish I knew how to make this bigger, but there's no option for me to do that. The first Jason. Anacapa Island, it's only 2 miles. We had our equipment in tents. And kids would come out, there's a pilot control, there's a teacher. We taught the teachers how to launch the planes. Our pilots, we worked with the students and taught them how to do it. We take instruments to take characteristic, every mission, what's the weather, what's the temperature, what are the conditions, what's the GPS measurements. And this was our very first educational plane. And it's the very first flight. And the students are operating, not the flight controls, but they're operating the payload. And our first one, they were snapping pictures, and then they could blow them up. And they were able to do the sea line counts, the berth, all of those kinds of things. The kelp. The plane has infrared sensors, thermal sensors, because we were measuring the currents. Because you have a warm current from the Gulf, you have a cold current coming down. And in between, it affects all the life, right at this boundary. On one side, you see little tiny sea stars. The other side, you see these huge sea stars. It affects all the life and the kelp that's there. And so this was our survey, and because it's a marine sanctuary, our plane, oh, I can't say that on film, never mind. So if there are any boats and they're dumping ballast waters, you have an infrared sensor, you can find that out. So here's some of the sea lines, and the kids were snapping the pictures, some of the land as well. From this, what we learned was the kids, we had a camera snap button, and we learned that kids don't snap fast enough. They still got 300 pictures, but now we put in every second. It automatically takes it, and it has video and thermal. But this was our first flight, and we only had a little bit of time to put this together, and the kids did the broadcast, and they shared and analyzed their data, and they put up posts for the people. The winds on both sides of the cliff were coming up, and the winds were fierce. Patrick Coronado is the pilot, and you'll see him just shake his hands and sweat, because, you know, it's like, is this gonna work live on camera? Is everything, and there he is in his hat. He wanted to be here today, but he has a NASA budget meeting in headquarters, program funded. And there's our explorer. And it's all about the kids doing the remote sensing. So after we did that, we were shocked because we were like, whew, those 4 weeks are over, we did it. And all of a sudden we started getting emails and telephone calls, and it was from all these scientists and all these teachers. And all these teachers said, I want to use the plane with my kids. And Patrick and I looked and went, what are the teachers gonna do? You know, what would teachers do? So we asked them, we said, if we gave you all this technology, what would you do? And so we apologize, because you can do quite a bit. And your ideas were great, and so we invested about $60,000 in equipment, because we loved everything you said you were gonna do. Now let me go back. Yes. Go back to my PowerPoint. So here's what the first teachers said to us. The teacher from Alaska said, I'm going to monitor glacial movement. I went, really? Yeah, because they're melting, so we need to monitor them and get this data. And we're like, well, what ground data? Who would your science partners be? And they sent us a mission, and we went, gosh, that's too good, Alaska. We got to fund it. And so we funded it. Snow albedo. People in Minnesota depend on the snow for their spring farming. Snow water equivalent. Oh, that's what we do here at NASA, measure snow water equivalent and snow albedo and changing surfaces. So we took that mission. The karst teacher was just great. This was an 8th grade teacher. She taught math and she was made to teach science. And she says, she sent a letter and she said, I have to teach karst. I don't even know what it is. Please help me. And we went, we gotta help this woman. So we brought her here and we put her with the NASA geologist. And I've got to tell you about her mission. There's a little town in Minnesota called Enkoff. And this little town, everybody's been getting cancer and dying. Everybody for 10 years have been getting cancer and dying. The cows have been dying, and the people have been dying. And the people got together in the community and said, something's wrong with the water. And so they went to the Water Resource Management, and they tested the water, and they said, everything is fine. And so this teacher, what she did was, she partnered with the Department of Natural Resources. And karst are little sinkholes. And there's this big sewer above the town of Enkoff. And it gets dumped. And so for years and years, people from the Department of Human Resources have been saying that water is getting into the drinking water and the farming land. But they couldn't prove it because there's like 1 million sinkholes and you have to be able to prove it. You have to be able to trace it down. So when the scientists saw the RSTEP equipment, the scientists said, we're changing your mission site, if that's okay with you, over to here. And what they did, I'm gonna put this down a minute. What they did was they put the kids to collect water, and they taught the kids all about it. And go to state missions, Minnesota karst, Minnesota karst monitoring. So when you get with RSTEP, you don't have to worry if you don't know the science. This is a professional development program for you, and one of the requirements is that we help you develop your mission. When you come here in the summer, you're going to meet with our expert scientists. We're going to give you feedback on what your ideas are already. But when you go home, part of the RSTEP program is you must partner with local scientists because they're the experts in your area, and they're probably doing research on what you're doing. And what's really neat is that after we go in, NASA goes in, teachers who have had no support from their districts, no technology, no support at all, when NASA comes in with technology, so many doors open, and the partnerships with the scientists continue, and it's the scientists who work with you and help you plan your mission, and it's the scientists who go into the classroom as experts and teach your kids the content. It's the scientist who decides, hey, this is the ground data I think you should be collecting. It's a scientist that helps you correlate your satellite plane and ground data. And you share this mission with the community. So it's involving the students in something that's important to them. Because NASA looks at the whole world, and that's important, but what's happening regionally? And you help us by your mission reports back. So here's the students, and they work with the geologists, and after they've learned the classroom part, they go into the field on mission day. And this student right here, the students are monitoring the data, but in this image, our infrared sensor was able to find the 2 sinkholes that have been missing. They'd sent teams out, they'd sent big planes out, and they couldn't find where it was. When they looked at a flyby in a test flight, if you can see underneath the infrared image, can you see the water line? Our infrared sensors can see underneath the surface of the land. And so they were able to follow right to Enkoff, right where it was. Then the next step was to prove it. So they got the kids out, and the kids started drawing the lines, finding the sinkholes, and that's a whole team that came out on a Saturday, just volunteer, and looking, they have to study karst, but then when you look at it firsthand, totally different story. The teacher, I was scared to death for her because she was 6 months pregnant, and she was in that field where the sewage leakage was, and baby's fine. And this student right here, she wrote a story about me. This is a student who never does his homework, never participates, can't stand school, but always comes. And when he was working with them, and he was collecting water samples and in charge of the analysis for that, he said, and found out that this could be a career. He means, I can get paid for this. And it turned him around. It was that one experience that turned him around. And here's the Department of Natural Resources hydrologist. They added dye to it just to confirm it. And if you look here, here's the sewer pond where it was being dumped. And what they did was they put their own dye in, but it was too late because the students and the natural resources had been out before they dumped it. And they knew they were going to do it. So they did this to prove where the dye would go, but it was too late. They had the entire town of Ancoff was immediately placed on bottled water. In Congress, they have been secretly fighting this out for a long time, and it turns out that there's a document, and it says, this sewer pond concrete will leak in 40 years. Tax each resident $1 for replacement. It was never replaced. It cracked, it was going in, it caused all these problems. So now they're still battling it out in court. But one teacher and a group of students, important to the community. So that was, and a teacher who didn't even know what karst was. Very proud of her. So these are the missions, cropland use. In Missouri, we had a teacher contact us. She teaches deaf students. And we're like, well, we don't even know how to do that. The strength of the RSTEP program is that you're the PI. The teachers are the leaders. You know your students, you know your community. We know the science. You plan the mission, what's right for your students. And we're going, well, we know the science, but we don't know how you're going to work. We have all these protocols now for working with deaf students because this teacher came and she wrote them and she knew how to do it. And in middle Missouri, corn. Do you plant it for fuel? Do you plant it for food? Now all of the land is being cleared for corn. How is that affecting Missouri? So Missouri cleared its land. They planted it. Some people planted for fuel. Some people planted for this, for food, because all of our stuff comes out of there. This year, they're facing drought. There is no corn. And she called me, she says, I got no cornfield to measure. I said, yes, you do. Your mission is the drought. Your mission is what has happened to the soil now. You know, your mission is now climate. And that's what she's doing with the kids. But these are missions important to the communities. Another one, invasive species is everywhere. In Michigan, they're doing the ash borer beetle. In Florida, in the Everglades, they're doing berries and all kinds of things. In Michigan, from one lake to another, it's blowing over from one lake to another. So the teachers got together 3 schools for each of the lakes to see what was blowing over. And that was part of their mission. So your RSTEP mission, in this one, the teachers propose ideas for the mission. What's important to your community? What is your science you have to cover? What would you like to do? What's important? The second step is that the teachers come to Goddard. Once you have your mission idea and your mission's approved, we take 12 to 15 teachers a year, and you come to Goddard. The first thing we're going to teach you is how to get satellite data of your area and how to analyze it in our computer lab and with tools. So we're going to show you how to do that, which satellites are best for your mission. The next thing, aerial platform, to give you a better view. We have planes and hexacopters all equipped with instruments. And so we're going to teach you so you can teach the students. We do not teach you how to fly it, because that's a no-no. Only AMA pilots fly it, and they're the experts that will come in and do aerodynamics in the classroom. The next thing, we have an array of all these field tools. Some are low-tech, most are very high-tech. Some of them are $10,000 spectrometers for some of the vegetation, so that it can be corroborated with satellite data. And we teach you how to use everything so that you are comfortable with it before you leave. Then we actually do a field mission right here with you. We end up doing 2 field missions, and just so you get the feel of implementing a real mission. Then you'll meet with the scientists, whatever scientist. If you're doing a geology mission, you're going to meet with the geology people. If you're doing a hydrology mission, you're going to meet with the hydrologists. and to get feedback and suggestion on your mission. So you've got that one-on-one support. After you've been trained at Goddard, there we go. Whoops. Oh, I hit it too many times. I apologize. Oop, let me see my slide up. That's what it is. I'm not in slide mode. There we go. There we go. Then you go back home and you meet with your local scientists to plan your mission, to go to your testing site, to go there with them and say, what data should I collect? Here's my mission questions. Are these the right questions? And what questions do the students have? And you're going to work with AMA pilots. We have a Space Act agreement with them. And after 9/11, my program was grounded. And we were not allowed to fly. So as a government person, we can't fly the planes anymore. However, these are hobby planes. AMA can fly them, and they're certified. So we have a Space Act agreement with them, and they'll come to your classroom, they'll go to the field, they designate a safety area, and they'll work with your students for the flight aspects. So they fly, and your students operate payload control for the field mission. And then the students, a mission day would normally have the kids prepping. You'd have 1, 2, 3, 4 flights. Most missions have 2 because that's plenty of data, but some have 4 to rotate their students. And in between the flights, the kids get out and they collect the ground truthing data. So then you go back to the classroom with the scientists and you analyze all your data. You corroborate it with the satellite data, and you share your results. What were your mission questions? You share your results with your community and what should happen next. Our new platform, this is a hexacopter. This is also a toy, but it's now a super educational tool. It didn't come with a ground station, it didn't come with separate controls, payload, but we have a hexacopter now, and the ability is, we got into swamps. Some teacher in Alabama, a Congaree swamp. And we were like, well, we can take off because we can launch our plane, but we need like 300 feet to land, and there's no place to land. We had basalt columns, and we needed to hover over the columns, so we needed a new tool. Every time the teachers tell us they need a new platform, we find it. And so what we did, this is a hexacopter, and it's got the same cameras and instruments as the plane, except for temperature, pressure, and humidity, and it has the ability to hover. It can go straight up and down, it can land anywhere. So for those tight spots, it doesn't need landing. This was just this past couple weeks ago, and this is 4th graders actually did this. Our program goes 4th to 12th grade. And this was 4th graders, and the 4th graders were doing the invasive species, and they were flying over, and they used our ROV to look for zebra mussels at the bottom, but for the plant life, the invasive plant life that had gone over the lakes, because they could only go in but so far. And so that was that. It went to White Sands, New Mexico this year, and they're monitoring the sand dunes and ecosystems. How are they changing? That mission and erosion that somebody had mentioned earlier. These are the basalt columns here on Earth, same as Mars. And you can see humans, we can't get too far. They're measuring the cracks from the water. And because of erosions, these will only last so long. So we needed a plane to get to the top, and we needed a hexacopter to go up and down the columns. And works all the way for college students too. The same equipment, but it's the teachers who decide how should it be used, because you know your kids better. And so they collected the data. This is those same columns in thermal imagery, so that we could see it much better than the human eye. We also have a new ROV that we got, and the students operate this entirely. We train you. When you're here, we'll take you to the buoyancy lab at University of Maryland, and you can see it. But we're also going to take you out on a boat in the Chesapeake Bay, and you're going to do a mission where you can't see it, because that's when you really learn how to navigate by the screen. And this is a teacher from Michigan who took the 4th grade students to a university pool to train their kids how to use it and how to look at the screen, how to navigate. The kids did that, and then the kids took it out and they did it in the Great Lakes to see the invasive species. These are high schoolers, and they did Chesapeake Bay replanting of grass. So they did that. So I guess what I want to know is, what kind of remote sensing mission would you be interested in? If you had these technologies available to you, what would you want to do? And if you go, no, I want to go watch, that's okay. But if there's somebody in this room who said, I'd love to do a mission, I know what I want to do, and I want to do this, and I would love to have some professional development in the summer, and I'd love to partner with scientists, and I'd like to have a mission at my school, well then, these are the things for you. And begin with the end in mind. What do you want your students to know and be able to do by the time your mission's over? That's a good way to start. Once you have your mission questions, what are your mission questions? Then, what data do I need to answer this question? And your scientists will be there to help you. What scientists in your area, who do you want to partner with? Is it the parks, the park rangers and scientists if you're doing a park? Is it Department of Natural Resources? Is it going to be Penn State University because you have that wonderful collection and all those people doing research there? Lots of options for that. Will your principals support you? You must have that, because you have to say, I'm coming to training and I'm going to implement. You have to have the permissions to implement. Normally, we loan the equipment to you for 4 weeks. So after you do the summer training, you go back, meet with your scientists, you get your scientists in the classroom with the content, plan and the mission, you get your pilots in the classroom, we send you the equipment, you do test flights, see what kind of data you're going to get. And you'll get the equipment for 4 weeks loaned to you during the school year. So, look what Pennsylvania, where is Pennsylvania? No, Pennsylvania, R-STEP teachers. Who will be the first R-STEP teacher? Do you remember the basalt columns I showed you? You have basalt columns in Pennsylvania. When I go up to Pennsylvania, in Clearfield, on the side of the road where the flag is, you have basalt columns. I'm dying to do those basalt columns. I might just do them myself because I want to compare them that are there. The other thing you have, which is so sad, every time I go to Pennsylvania, I'm so sad to see, the mountains will turn to dust. I used to think, what could make the mountains turn to dust? Well, strip mining. I am watching your beautiful Pennsylvania mountains, one after another after another. Those mountains protect you as well. You've seen the West and the tornadoes and Tornado Alley. Those mountains protect you. And all of the resources that are in them are being mined, but what data will we have for those mountains? And what is that strip mining doing to your water sources? But there might be other areas. The things we don't do. A lot of teachers say, I want to study population growth and how my land has changed. And that's fine, you can do that, but you can't fly. You can use the satellite and ground tools, but you cannot fly. We cannot fly in populated areas, roads, houses. When those missions come in, we go, oh, we told you before you began. We can't do it. And they're automatically eliminated. How do we select our teachers? The way we select our teachers is, because it's a nationwide program, the way we select our teachers is by the missions. The first thing, the R-STEP team does the first review, and we make sure it meets the criteria. We make sure it's an earth science mission. We make sure that we can do it and we can support you. It's something we can support. And if it's flying in an area, populated area, as great as it is, it's tossed. Then we take the missions that have met the criteria and we take them over to NASA Goddard Building 33, Earth scientists. And the Earth scientists evaluate them and rank them. And then the top 15 come back to us. And then we look at it for the R-STEP. We send it to Equal Opportunity in the Education Office, and they look at your school graphics, because we want to try to, get the underserved. We try to also look for where are these teachers that have no help. And then Patrick and I, we'll take their recommendations, but then Patrick and I look at all of the missions, and if we see a teacher who says, I have to teach Karsten, I don't even know what it is, please help me, then we go, yeah, we gotta take this one, let's just add on. And we'll take an extra teacher sometimes that way ourselves. Now, like all the programs, I'm sure you've heard, NASA under the sequester, our budget has been cut. And so my question was, when they asked me to present this program, I was like, well, why would I present this program if we don't have funding? We have the equipment and we have the people all available to you. We no longer, we used to pay for teachers to come and stay a week at the hotel. We no longer have the teacher travel. We no longer have shipping, the cost of shipping the equipment to you and shipping the equipment back. But I was asked to present anyhow by Dr. Morgan and Evelina and Patrick to see if you were interested. And if you're interested, and the PA3 program wants to fund you to come next year, then we're going to reserve a hexacopter and a plane for you. And we'll work with you all during the year so that you can do this. Now, who are the people who are interested? Great, come on up. Where's my payload team? Come on up. Here they come. They said, what have I done? Come on up, really. Go get your hexacopter. Where are the men? Boy, no men raise their hand. Look at the women. Women in science. My goodness. Sir, will you raise your hand? Will you raise your hand?
Sure.
Thank you for volunteering. And that's how you do it in the classroom. So bring your payload, bring your table, bring your payload, bring all that stuff over, bring your hexacopter over. Okay, take your, oh, you're the ground station person. Okay, flight, no, you're the flight. Head of flight operations. Here, take your stuff out. You want to probably put that on the floor. And then you probably want to turn it, lay it down, yep, and open it up and get out your hexacopter. You're the ground station person, so take out your ground station. Oh, power. Where's the power? We'll use batteries. We'll use batteries. I don't know if we have a key. Here's a key. Do we have a quarter? Ah! We're moving the table. Okay, take your hexacopter out carefully. All right. They are so careful, and that's what we want. Nice and careful. If you just lift it straight up, careful, 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 and bring it over to your table. Our hexacopter payload team. You're getting all your stuff out. Great. Okay, so you need these plugs in and turn this on. Okay, payload specialist team. Okay. This is a hexacopter, and you can buy it in any hobby shop. And you pay like $300 for it. And these are the motors on it. We slapped a GPS on it. We slapped downlink. But it's the cameras and thermal sensors that are so expensive. This is now $40,000 worth of equipment. And GPS.
We were careful with it, that's a good thing.
Did we get the right team? I hope we got the right team on this here. And so now what we're going to do is my payload specialist team. Okay, here you go. This is the payload battery. Everything's lithium and polymer to last. And this is a charging cord. But what I'm going to do is I'm going to have you take a look at those two ends, because it matters. And we're going to have you plug in your payload. I'm going to turn around so the camera's going to face you guys. No, really, I won't let anything happen to it. Truly, truly, truly. This is your payload right here, and so I'm going to have you connect the payload battery. Oh, there's already one right here. Can you just connect this for me? Payload specialist. And the cameras have begun. There's lights on my side. I don't know if there's any lights on your side or not. And you've got your receiver on. Now, in order to connect it to the ground station, we made all these cables up. Oops. Let's go ahead and connect this into here. Flight specialists, don't turn that on, whatever you do. The red bar is the front, so you know the front. And now, if our computer, here's our receiver for this one. In the front, there should be a receiver in that bag. Looks like one of these. Oh no, here it is. Okay. If we can plug this, I don't know if you can find over there on the wall or anything, if you can find these two on the computer, we'll be able to put everything up on those screens. So you'll be able to, in the classroom, wireless receivers. Is there anything over there that... Let's put it in the computer. Okay, we'll try. We'll try to put this, might be a dampening thing, we'll find out. But in your classroom, you'll be able to do that. And right now, it's on the thermal. So, another payload specialist. He says, I came up here, separate controls, separate pilot and student controls. So you have a ground station team, and your ground station team would be taping and collecting the data for analysis in your classroom. And it has two imagers on it. And so go ahead and turn your unit on. Right here, turn it to the right. And you have beeped out, and get your antenna going. Okay, now this button right here is going to, see how that just turned green? Yeah, that turned green. And you turn your cameras on and off, and you're gonna slew and tilt between them. And so on the little screen, we can see a chair, and now let's angle it. Tell me, here, you're the observer. Tell me when I've got this person right here in the red chair. Do we have him yet? On the screen?
Move the camera.
Payload person, give the payload person some direction. Tell him move his camera up or down or up. Do we have him?
Got it.
Okay, now, somebody turn out the lights over there.
That's thermostat.
Oh!
Over there.
Thank you, tech people. It goes in the video and, okay? All right, and let's have that young man, let's have him stand up. Is everybody seeing the thermal imager? Let's have him stand up. Now move away from your chair. Either way. Okay, do you have heat from his chair?
Yes.
We have heat from his chair. Now let's take her footprints. If you'll come walk over here, madam. Are we getting any of her footprints? Because we're getting light from the screen, but did we get any of hers?
We got it.
Okay, good. And now, so it's high tech and very sensitive. And the things that you do in your classroom when you have to teach thermal. But this is good for temperatures. And when we use our ground tools, even though this is color phase, then we know cold, black and white, medium gray. Then we can assign values to it. And then we can corroborate the satellite data as well. I don't know what they're doing. But anyhow, I'll have you switch to visible.
Who says we?
Payload guy.
Oh, there it was.
Oh, they almost had it. Oh, they're working on it. I don't know what to say. They got NASA TV in orbit. Okay. If you're gonna go ahead and switch to visible, go ahead and switch to visible. Now on the little screen, are you getting visible?
No, not yet.
Payload guy. Okay. Okay, this is going to be your, okay, and then swing it down, and then switch. This will be switching you back and forth. Okay, is the visible on? Can you tilt your visible a little bit?
Yeah, there you go.
That's visible.
Okay, and there's all of you guys. So if you're going over an area and you're like, oh, there you go. And now look at your glasses. Those of you with glasses, blocking, yeah, I'm going to take off your glasses. Hold up your hands. Who's somebody who's always hot and somebody who's always cold? Forever cold. Nobody with cold hands, you're all pretty warm right now. But to look at the thermal, now let's go back to visible. Payload operator. Can you go back to visible? Okay, so take your slew that's by your thumb. That's good. Now take your slew by your thumb, the big one. Yeah, push it down. Okay, that's your tilt. All right. And then these two. This is going to be your. There you go. We got you. And oh, not much color. That's antenna. That's probably antenna in here as well, antenna receiver. But this is that part. Okay, so we're going to just take that. Now the flight people, flight battery. One of the things that charging, teachers are never responsible for doing any of the charging of LiPo batteries or anything else because it's dangerous. We had a teacher actually do it. We said, don't do it, don't do it, don't do it. We had a teacher do it. And the whole battery puffed up and they're like, what do I do, what do I do? And it's like, don't do that. You know, they're supposed to. The pilots know how to do this. And the teacher didn't even have it in the safety bag, but all of our batteries will always arrive in the safety bag and we'll teach you. And this is a flight lithium battery. You can fly for about 28 minutes. We don't recommend that because it's far too much data. Keep your flights like 8 to 10 minutes. You get tons of data that way. Now I'm going to ask my flight person, I'm just going to borrow the controls from you guys. Because one of the things that the pilot would know to do is all these switches should always be away from you. And this one should be down because this one arms it. And I wouldn't want it to take off and hurt you. So what we're going to do is while I have this, I'm going to turn it on, but I'm not going to arm it. I'm going to give this to you. Don't do anything. Okay. Those of you sitting there, hope you can follow directions like your students. Flight. Here's the flight person. You're going to come connect us, but when you do it,
I'm getting close to this. Do not arm it.
but when you do it, the propellers are going to go. So do it right here, and keep your hands away from the, don't get hurt. You just ruin the whole program. Don't get hurt. Okay. And this is and now it's armed. How are you?
I'm good.
Don't touch anything.
I'm not.
Because you're not a pilot. So you can just, and we don't let the students, and this is why we have separate controls. The first time we didn't have separate controls, and we went, we need separate controls, separate on and off. It's beeping because it's waiting for us to take off and to do something, but we're not. And the lights help us know where the front is. We can do night flying. And the hexacopters, they can go straight up, they can hover, you can tilt the cameras, and so it's a great way to study what you want to study. All right. Different instruments, payloads, yes. Now, don't move. Now you can go off. Now you're safe. She's not a pilot, so they let her fly it. And wherever we fly and wherever we collect data, so planes are good for getting large areas. Hexacopters are good for if there's no place to land, if you need to hover. They have pretty much the same instruments. The plane carries a little bit more. Our payloads are about 2 pounds. The other one I didn't show you yet. Did I show you the ROV? Yes, I did. And we have the ROV as well, and the collection ground truthing. So I think, give these people a hand. They are so good. Thank you.